Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about one more example of the random process. The example is given x bar is 6, that is expectation of x of t is equal to 6, and rxx of tau is 36 plus 25 e power minus tau for a random process x of t. Indicate which of the following statements are true based on what is known with certainty. So the random process x of t, the first bit is x of t is first order stationary, and second bit x of t is has total average power of 61 volt, and third bit is x of t is ergodic, and fourth bit is x of t is wide sense stationary, and fifth bit is x of t has a periodic component, and sixth bit is x of t has an AC power of 36 watts. Coming to the solution, given that expectation of x of t is 6 and autocorrelation function of x of t is rx of tau is 36 plus 25 e power minus tau. And first bit solution, since the mean value of x of t is constant, the first order density function does not change with the time. Therefore, the random process x of t is first order stationary process. That is the first bit solution. And second bit solution, we know that the average power is expectation of x square of t, which is equal to rxx of 0. Given that rxx of tau is there in the given autocorrelation function, substitute tau is equal to 0, we get expectation of x square of t. So which is average power of the random process x of t. So therefore, the average power is 61 watts. And third bit solution, if the process is ergodic, the ensemble averages is equal to time averages. So now we are given that the ensemble average or the statistical average value is 6 and time average a of x of t. So a of x of t is equal to 6 and time average autocorrelation function is equal to ensemble average autocorrelation function. Now here given that statistical or ensemble autocorrelation function is 36 plus 25 e power minus tau. So therefore the process is ergodic. The next bit solution, the condition for the process to be WSS is expectation of x is equal to 6 is constant and autocorrelation function is independent of absolute time. Now the autocorrelation function depends on the tau. Depends on the tau means that is independent of the time. Hence the random process x of t is a wide sense stationary random process. Next bit solution, the process has no periodic component. Since expectation of x whole square is equal, limit tau tends to infinity rxx of tau. So given that rxx of tau is 36 plus 25 e power minus tau and substitute tau is equal to infinity, e power minus infinity value is 0. So expectation of x of t whole square is equal to 36. Expectation of x is equal to 6. Next find out AC power of the random process. So we know that variance of x is equal to expectation of x square of t minus expectation of x of t whole square is the AC power of the random process. That is the variance of x of t. So now here expectation of x square of t is 61, that is already calculated, and expectation of x of t is 6, 6 square is 36, 61 minus 36 is 25. So therefore the AC power is 25 watts.